Hello everyone. Today we are working on the 8-4 notes, solving logarithmic equations. Everyone is doing this from home, so hopefully these notes are good since that's how you're learning it. First thing we're going to do is solve some logarithmic equations. Key thing is we are going to rewrite them as an exponential function. So remember that is my catchphrase of pop it. All right. So first one we have is log base x equal to 3/4. So we're going to rewrite this as an exponential. We're going to move the 81 over. It pops the 3/4 up. That's equal to x. What is 81 to the 3/4? Well, that remember means the fourth root of 81 cubed. The fourth root of 81 is 3. Cubed is 27. So x equals 27. Next up, number 2, log base 25 of x equals 5/2. Again, rewriting it as an exponential, that says 25 to the 5/2 is equal to x. 25 to the 5/2 means the square root of 25 to the 5th. The square root of 25 is 5, so we're left with 5 to the 5th, and 5 to the 5th is 3,125. Next up is log base x of 27 equals 3/4 or 3/2. So again, rewriting that as an exponential, x to the 3/2 equals 27. Now what? Now we have that 3/2 power. We need to get rid of that. So we're going to raise both sides to the 2/3 power. When we do that, the 3/2 and the 2/3 get us a plain x, which is what we want. Then on the other side, we will have the cube root of 27 squared. Easier to do the cube root first and then square it rather than 27 squared and then have to go back and figure out the cube root. Cube root of 27 is 3 squared. That gets us x equals 9. Next up, number 4. We have log base 3 of 4x minus 17. So a little bit different because there's a little bit more going on. We're going to solve it the same way. Rewrite it as an exponential. 3 to the 5th equals 4x minus 17. 3 to the 5th power is 243 equals 4x minus 17. Add 17 to both sides. 4x equals 260. Divide both sides by 4. And x equals, I'm going to cheat a little bit, use some calculator help, x equals 65. Next up, number 5, you say, okay, I'm going to pop it. I'm going to rewrite it as an exponential. That gives me 4 to the x plus 5 equals 256. You say, ugh, well, that's not very helpful because now the variable is in my exponent. So if you look at the original problem again, we have log base 4 of 256. That's just a number, right? That says 4 to what power is 256? Well, 4 to what power is 256? The fourth power. So log base 4 of 256 is really just 4. Subtract 5 from both sides, and we get x equals -1. So I know we're quick to rewrite it as an exponential, but sometimes that's not helpful because maybe you can simplify something first and then deal with solving the equation like we did in number 5. Okay? All right, next up, properties of equality for logarithmic functions. If b is a positive number other than 1, we've said numerous times now, b, the base, has to be greater than 0 and cannot equal 1. Then, log base b of x equals log base b of y, if and only if x equals y. So just like we did in the exponential equations, get the bases to match, the exponents have to match. Here, we're going to get the log base part to match. And if those match, then what you're taking the log of, those have to match. For example, If I have log base 5 of x equals log base 5 of 8, our logs match, our bases match. So then what we're taking the log of, those have to match, so x has to equal 8. I'm not going to try and be tricky on any of these and have the bases not match or anything like that. It's just about getting those bases to match. Now, when we are solving these, we have to check for extraneous solutions, those extra answers that maybe don't work when we plug it back in. We can only take the log of a positive number. We can only take the log of a positive number. So if we plug it in and we get a negative number, we've got a problem. All right, let's look at number 6. We've got log base 3 of 3x plus 8 equals log base 3 of x squared plus x. So we know then that the 3x plus 8 has to equal the x squared plus x. This is a quadratic, so I want to move everything over to one side. I find it much easier to factor when the leading coefficient is positive, so I'm moving everything to the right-hand side. We get x squared minus 2x minus 8 equals 0. Let's factor that. We get an x, we get an x. Two numbers that multiply to 8, 2 and 4. We need a negative 2 in the middle, so that's negative 4 plus 2. Set each factor equal to 0, and then we get x equals negative 2, and we get x equals 4. Here's where we have to plug them back in and make sure we don't get any of those extraneous solutions. If we plug in the negative 2, we get 3 times negative 2 plus 8. Does that equal negative 2 squared plus negative 2? Let's see, we get negative 6 plus 8 is 2. We get 4 minus 2 is 2. And I take the log of 2. I can, so those work. So that's a keeper. Then we plug in the 4. 3 times 4 plus 8. And we look at 4 squared plus 4. We get 12 plus 8 is 20. 16 plus 4 is 20. 20 equals 20. Can I take the log of 20? Yes, I can. So that's a keeper as well. Number 7, let's look here. We've got a log base 12. We've got a log base 12. Since those match, what we're taking the log of has to also match. So x squared minus 7 equals x plus 5. Again, a quadratic. So I want to move everything over to the left this time. X squared minus x minus 12 equals 0. Yay, this one factors. X minus 4x plus 3 equals 0. Set each factor equal to 0. And we get 4 and negative 3. All right, and then we're going to check. 4 squared minus 7, does that equal 4 plus 5? 4 squared is 16 minus 7 is 9. 4 plus 5 is 9. That matches. Can I take the log of 9? I can, because it's a positive number. So we'll keep the 4. Then we plug in the negative 3. Negative 3 squared minus 7. 9 minus 7 is 2. Negative 3 plus 5 is 2. Can I take the log of 2? I can. 2 equals 2. Therefore, the negative 3 also works. Try number 8. Log base 2 of x squared minus 4 equals log base 2 of 3x. So x squared minus 4 equals 3x. Again, a quadratic. Practicing some quadratics here. X squared minus 3x minus 4 equals 0. Factor x minus 4 and then x plus 1 equals 0. So x equals 4 and negative 1. Plug them in. 4 squared minus 4. Does that equal 3 times 4? 16 minus 4 is 12. 3 times 4 is 12. Can I take the log of 12? I can because it's positive, so we keep the 4. Plug in the negative 1. Negative 1 squared minus 4. 3 times negative 1. I get 1 minus 3 is negative 3. 3 times negative 1 is negative 3. Negative 3 equals negative 3. So I know I did the problem right, but I cannot take the log of a negative number. I cannot take the log, I don't care what your base is, In this case, we had base 2. That is a big can't do it. So what does that mean? That means the -1 gets tossed out and just the 4 works. Last one, number 9, log base 4 of 2x squared plus 1, log base 4 of 10x minus 7. The bases match. So what we're taking the log of also has to match. I'm going to move everything over to the left. 2x squared minus 10x plus 8 equals 0. If I notice I can take a 2 out of all of those numbers, so I'm going to do that. I'm going to divide everything by 2. Why am I going to divide everything by 2? Because then my numbers are smaller. This is way easier to factor. So when I factor, I get x minus 4, x minus 1 equals 0. So x equals 4 or 1. What goes back in? 2, 4 squared plus 1, that's 16. 32 plus 1 is 33. And on the other side, I have 10 times 4, whoops, out of the showing zone here. 10 times 4 minus 7, 33. Those work. They're equal. It's a positive number, so I'll keep the 4. Then I plug in the 1. I get 1 squared, 1, 2, total of 3. Plug it in on the other side, 10 times 1 minus 7. I get 3. 3 equals 3. 3 is a positive number, so I'm going to keep both of those as well. All right. So that is how we solve log equations. Pretty easy because they're all nice and neat. Log base equals log base. The bases all match. Next up, when we start looking at the future, we're going to have to do a little more work to get those things to match up before we're able to get started. Okay, go ahead and try those homework problems tonight. Hope you guys have a great weekend, and I'll see you next week. Thanks. Bye.